what was the definition? So the sine z
e to the I z minus e to the negative I z over 2I.
over 2I. That's
From the definition, the exponent.
over plus or minus? You sure?
Minus, yeah. The cosine is plus and there's no I.
Let's just make sure. This is
Way back. There. This is
okay, good. And cosine z. Okay, let's start with the sine. We'll come back to the cosine. Let's just write the cosine here, just so we can have it. Cosine z is e to the iz plus e to the minus iz over 2. Yeah?
yeah.
Okay, find the derivatives, yeah? So this is okay, let's see what's the easiest way to do this. So this is fz, yeah? So this guy here is fz. Okay, now what's the definition of the derivative? So df over dz is the limit of delta f over delta z as delta z goes to 0. Okay, now what's delta f? Delta f is f of z plus delta z minus f of z, right? Over what's delta x, delta z? Well, z is x plus iy, so delta z will be delta x plus I delta y. You follow? Actually, let's leave it as delta z for now. We may not need to switch it. We'll see how things go. And then when we're done, we will take the limit as delta z goes to 0. You see? Now, what's f of z plus delta z? You replace every z with z plus delta z. So so df over dz will be e to the I into z plus delta z minus, so I'm doing the sign now, e to the minus I into z plus delta z, yeah, all over 2, so this is all over 2I, okay, minus the original, e to the iz minus e to the, you know what to do now, minus iz over 2I, and this is all over, let me put the main divider here, so this is df over dz, so the main divider is here, and this is all over delta z, and at the end we're going to take the limit as delta z goes to 0. Okay, let's see how we're going to simplify these. Should be easy actually, because now we can separate these into e to the iz times e to the I delta z, right, minus e to the minus iz minus e to the minus I delta z. They have the same denominator, so I could just merge them, so minus e to the iz plus e to the iz all over, so 2I can multiply here, yeah, so it just can sit here over 2I, and then when we're done we'll take the limit as delta z goes to 0. Okay, you can't plug in delta z 0 as of yet because the denominator will go to 0, yeah. Let's see what we can do. Well, let's oh wait, this is times here, not minus. Okay, well, I can group these two terms together, the ones that has e. Does this help? Let's see. So we have e I z, so I will group this term with this term here into e I delta z minus 1. Okay, minus e to the minus iz. Oh, this is minus iz. So e to the minus iz into 1 minus e to the minus I delta z. Okay, and this is divided by delta z, and this is divided by delta z, and there's 1 over 2i outside. Okay, where does this take us? Let's see. And then when we're done, we're going to take the limit as delta z goes to 0. Right? That's 1 over 2i. This is cosine delta z. Oh yeah, when you break them into cosines and sines, you could do it. So this is cosine x minus I, cosine delta z minus I delta z. Yeah, minus sine I sine delta z minus 1 all over delta z. Yeah, now it works, because what's the limit of this as delta z goes to 0? 1. This is sine u over u. So yeah, so now we can separate this into 1 over 2i. Yeah, let's do it in steps. So iz, e to the iz. Right, let's split. So I rewrote e to the I delta z as cosine delta z plus, this is supposed to be plus I sine delta z. So this becomes cosine delta z minus 1 over delta z, and we will take the limit of this as delta z goes to 0 plus I sine delta z over delta z, and now we will take the limit as delta z goes to 0. Okay, now by definition this is 1, and by definition, if you remember calc 1, this is 0. The first one is 0. The first one is 0. Okay, good. So on the first part we are getting e, so 1 over 2i, and then we have left e to the iz times I. Okay, now continuing on, the second guy, same thing, split it up. This is minus e to the iz, yeah, and then this becomes 1 minus, so this becomes 1 minus cosine of minus I delta z, minus delta z. So we are using the definition of the exponential to FOIL this guy here. We need room. So we're using the definition of the exponential. So 1 minus cosine minus delta z, right? Plus minus delta z minus plus I sine minus delta z. Okay. And this is all over delta z. Okay, so I could put delta z underneath this guy, and I could put delta z under, let's leave it, we'll expand it now in a second. Okay, and now let's continue it here. So let's move all this stuff. To the left. Okay, so minus, continuing in red so we can distribute it from the differentiate it from this one, minus I z. Okay, let's do the same thing we did there. So this becomes 1 cosine minus delta z is the same thing as cosine delta z, so this becomes 1 minus cosine delta z. Cosine is an even function over delta z, right? I could pull the minus sign outside if I want. Doesn't really matter. The limit will not change. The limit as delta z goes to 0, this is 0, right? This is minus, so this becomes minus I sine delta z over delta z, and we will take the limit as delta z goes to 0. We know that this guy is 1. So now the second term turns out to be minus, similar to the first term, yeah? Minus minus plus, so this becomes plus I e to the minus iz. Oh, neat. Okay, so this is df over dz. Okay, continuing on. So df over dz equals, look, if you pull the I out, you get e to the iz plus e to the minus iz, right, times I over 2I. Well, let's simplify that. Multiply, cancel the out, or actually, yeah, you could cross out the I, right? You could cross out the I. Fair enough. And if you do that, right, or multiply up and down by I, you get minus 1 over minus 1. So you end up with e to the iz plus e to the minus iz over 2. And what's this? Cosine. So this guy here is cosine z. So what we've actually found out using the definition, the definition of the limit in complex functions, and some basic formulas, definitions from Calc 1, that d over dz of sine z is actually cosine z. Surprise, surprise. Well, I shouldn't say that, because sometimes the results are different in complex functions versus real valued functions. An example on that would be the absolute value of x squared. That really doesn't turn out to be the same in both worlds. Yeah, in real valued function versus complex functions. So yeah, so this is the first one.
Okay.
Makes sense?
Yeah, well, how does that, I basically...
So for the cosine, the same way. So d over dz of cosine z equals d over dz of e e to the iz plus e to the minus iz. So this is the definition of the cosine, over 2. Okay, and again I'll use the definition of the derivative. So this is so the definition of the derivative is df over dz is f of z plus delta z minus f of z over delta z, and I will take the limit as delta z goes to 0. Yeah. So we have f of z plus delta z, so this becomes e to the I. Replace z with z plus delta z first, plus e to the minus I z plus delta z all over 2. This is just f of z plus delta z minus f of z, which is the original, e to the iz plus e to the minus iz over 2, and this is all over delta z. And when we're done, we will take the limit as delta z goes to 0. Okay, so let's split this first one up. So eiz I delta z is e minus iz plus e minus I delta z over 2. I'll leave the half out. So minus, and then we'll FOIL this. So this is minus, it's the same denominator, yeah, eiz minus e to the minus iz all over delta z, and then we will take the limit as delta z goes to 0. Okay, now let's combine the terms that have iz together. Oh wait, oops, made a stupid mistake here. This is multiplication. What to do? This is multiplication. Okay, so let's collect the terms that have iz. So we've got this guy here, okay, so we're gonna collect the guys that have iz, so this guy here and this guy here together, and we will collect together the ones with minus iz, and okay, and then from the ones with I will factor out e to the iz, so we have half e to the iz into e to the I delta z minus 1. Okay, and then I'll factor e to the minus iz from the second guy, and so I will have left e to the minus I delta z minus 1 all over delta z, and then we'll take the limit as delta z goes to 0. Okay, now at this point we will use the definition of the exponential on this one and on this one. So we will get 1/2 limit. How we doing? Good. iz, oops, into so it's e to the I delta z. The definition of the complex number is cosine the angle, cosine delta z plus I sine delta z minus 1 plus same thing here, e to the minus I delta e to the minus iz, and let's take this a little bit left. And move this a little bit to the left so we can have room. Yeah. Cosine minus delta z minus or plus I sine minus delta z minus 1 all over delta z, and the limit as delta z goes to 0. Okay, so let's split these babies up. So limit as delta z goes to 0. Okay, we will take this together with this, so this is cosine delta z minus 1 over delta z, and I will distribute the limit, so the second one will be plus I sine delta z over delta z, and this one also has a limit as delta z goes to 0, and this whole thing is multiplying, let me write it here at the beginning, e to the iz. Okay, and we will do the same exact thing on the second term. Let's use this color for that. So plus e to the minus iz, and cosine minus delta z will just be cosine delta z, even function, minus 1 over delta z, and we will take the limit of this one as delta z goes to 0. Plus I, well, sine minus delta z is minus sine delta z over delta z, and then we will take the limit of this as delta z goes to 0. Okay, and also there's a half on this guy. Okay, now this is 0. I mean, if you want to be fancy on this one, you could say, okay, well, if I plug in 0 for delta z, I get 1 minus 1 over 0, 0 over 0, use L'Hopital's rule, take the derivative of cosine, becomes minus sine, right? The bottom is just 1, so you get minus sine 0, which is 0. So either way, you get 0 for this one, doesn't matter. And this one, you can also, if you want, apply L'Hopital's rule on this one, because you get 0 over 0, then you get cosine delta z over 1. Cosine 0 is 1, so either way you get 1 for this one. The same exact argument applies here. 0, 1. Okay, so this simplifies greatly, and we get 1/2. So from this first term here, all we have is 1 times I, so that's I e to the iz, and from the second term we have 1/2 e to the minus iz, and then we also have minus I, right? Multiplying minus I, so we can make this a minus, and this here is an I. Okay, great. That's all we have. So now factor out the I, yeah, or half I. We will get e to the iz minus e to the minus iz. And what's the definition of sine? Sine is, let's see, over 2i, e to the iz minus e to the minus iz over 2, right? Let me make sure here I don't have a sign mistake. E to the minus iz. Yeah, no, everything is working. Okay, so yeah, that's fine. So so to turn it around, I'm gonna multiply here by I and down here by I, yeah. And so if I combine these two i's here, I will get I squared, which is minus 1, so minus 1/2, and then I'm gonna pull this I to the denominator of these, iz minus e minus iz all over. Let me borrow this 2 and just make this 2i. There we go. And what is e to the iz minus e to the minus iz? Isn't that cosine z? I mean sine z? Yeah, that's exactly sine z. And so this is sine z. And so what we've got at the end, therefore, that d over dz of cosine z is minus, because there's this minus sign left here, minus sine z. So the derivatives of the trig functions sine and cosine turned out to be the same as the real valued functions, cosine x and x. Yeah, turned out that the derivative of cosine z is minus sine z, and the derivative of sine z is cosine z. And last but not least is to find the derivative of cotan. Yeah, cotan. So let's do d over dx dz, d over dz of cotan z. Well, d over dz, cotan is cosine z over sine z, right? So I'm going to apply the quotient rule, because that holds also for complex valued functions. So and it's in problem 27, correct? It's in problem 27, stated in problem 27. This is the quotient rule for complex valued functions. So right, so cosine, we proved it's minus sine z just now, times the top as is, times the bottom as is, sine z, minus the top as is, derivative of sine z, which just proved is cosine z, all over sine squared z. So we get minus sine squared z minus cosine squared z over sine squared z, right? and so this becomes minus 1 over, because cosine squared plus sine squared is 1, sine squared z. And what's 1 over sine squared? Minus cosecant squared. So the final answer, d over dz of cotan z equal minus cosecant squared z. And to be in the domain here, to obey the domain, z cannot be any multiple of pi.